Okay, this video is on aromatics, and aromatics are compounds that are formally related to benzene, which has the formula C6H6. And if you look over here to the right, you'll see this structure right here is a simple or a simplified version of benzene. If you remember in previous videos, we've talked about the fact that you can do a shorthand for what you're drawing out. Rather than drawing each C, each point is assumed to be a C, and then each line is a double bond. So it's showing that they have alternating double bonds. Some books will show it as a hexagon with a circle in the middle. And what that represents is that those double bonds are delocalized. They are not specifically between any two carbons in the molecule. They are somehow shared between each of the 6 carbons equally. We call that a resonance structure when you can draw, when no one picture accurately represents the structure. Anyway, the name aromatic became popular because the earliest compounds that had these benzene rings had pleasant fragrances, but the ring really doesn't have anything to do with the smell. So after a while, they became aromatics, but that's not really actually an accurate name. A lot of aromatic rings are given common names. One of the most common ones is toluene, and sometimes you will see that. A toluene molecule is a benzene molecule. So I'll draw it with the circle, a hexagon with the circle. That is different, by the way, than cyclohexane. Cyclohexane has all single bonds. So be careful when you're naming compounds. A cyclohexane has all single bonds. This is a benzene structure here. Now, if we were going to draw toluene, a toluene has a methyl group on just one of the carbons. So this right here is a common name of toluene, not to be confused with any of the cyclo compounds. Now, toluene is not technically how you would name this officially. We're going to learn the rules for naming by reading these here. So if we're going to name aromatics, first of all, sometimes the chain is, if we look at this example, sometimes this chain is long and this becomes the substituent. And sometimes this is the substituent. Generally speaking, if this chain here is 4 carbons or more, we consider that the parent chain with 4 or more. Otherwise, the benzene is the parent and any group attached is a substituent. We'll show you what I mean in an example here. So first of all, you name these very similarly to alkanes and alkenes and alkynes. You want to obtain the smallest possible numbers to locate the branched alkanes or anything that's off of the ring. So you can start at whatever substituent you want, but you want to go clockwise or counterclockwise to get the smallest possible numbers. So you would never have a 1 and a 6. You would have a 1 and a 2. Then you're going to identify the various branching groups, whether they have 2 or 3 carbons or 1 carbon. You know how to name each of those. Now, rule 3 is kind of important. If the benzene ring is considered the branch in larger molecules, generally 4 carbons or longer, then the benzene ring is the attachment, and it's called a phenyl group. In this case, the alkane is the parent chain, and the phenyl group, the benzene, becomes the branch of the alkane structure. This is an example here where you have a parent chain of 4 carbons, 1, 2, 3, 4. So instead of saying that this is somehow a butyl benzene, what we call it is a 1-phenyl butane. Now, we'll practice with these. So if we look at the first example, it says to name the following. And as always, if you want to pause the video and try it yourself, you certainly can. But what we would look at is we have a benzene ring, and attached to this is a methyl group. So the benzene would be the base part of the name, and we would just say methylbenzene. We don't need to write a 1 in front of it because if it's the only attachment, it is assumed to be on carbon number 1. Similarly, that's how we would name this second compound here. This is an ethyl group, so this would be called ethylbenzene. Again, the 1 does not need to be stated because it's the only attachment given. However, if there are more than 1 attachments, So for example, we'll draw a benzene, and I am going to put a CH3 group here and a Cl group here. We still want the parent chain to be a benzene, but now we look at our attachments and we have a chlorine and we have a methyl. Now, if you remember back to your alkane video, we'd like to list substituents alphabetically. That means chloro would go before methyl. So we'll call this the 1 carbon. And it's numbering counterclockwise that will give us the lowest possible numbering system. So we'll call this 1 chloro, 3 methyl, benzene. Hopefully that gives you a pretty good overview of aromatics.